Hello everyone. I'm really happy that we are starting the 14 sessions and the last session of our cognitive neuroscience course from basic foundations to pragmatic clinical applications. And I'm trying to make a sort of wrap up today about what we have discussed during last 13 sessions and give you an idea about what we can do in the future and what are the potentials for you to become a cognitive neuroscientist if you are getting more interested to the field of cognitive neuroscience. So that would be the overview of what I'm gonna do today for the next 2 hours. So be ready for a long session like the last sessions that we had, and I hope that you will enjoy that in terms of the applications in long term for yourself. But even starting from the first slide, when we talk about being successful in the field of cognitive neuroscience, it could be questionable for a couple of people in terms of what do we mean by being successful. And here by successful, one of the main connotations that I'm employing right now is about being impactful. And by saying impactful, we can have different dimensions of being impactful. Being impactful in the clinical applications, being impactful in the community, being impactful in the global level, being impactful in terms of the scientific production, being impactful in terms of directing scientific and global scientific discoveries around the world. So there are many aspects of being impactful. But what I'm talking about being successful, I mean trying to consider all these aspects of being impactful in long term. And I hope that many of you who are already attending this course would be really impactful cognitive scientists in the future. So let's start with this question that, okay, we are right now close to the end of 2020. And the question is, okay, in the next 10 years of your scientific journey, in the next 10 years of your life, at the age of something like, let's say you are 30 years old at the age of 4 years old, or let's say this year is 2020 at the year of 2030. What do you like to be as a cognitive neuroscientist, or what do you like to be in academia or in clinical practice or whatever in your scientific life? Please tell us about that. So just start to think about what would be the position that you like to have in 10 years from now. And please write down your kind of long-term plan for that in terms of, okay, what do you like to be 10 years from now? And then, in 10 years, we can go back and see, have you been successful in making that happen or not? I definitely would love to do that in terms of contacting you in 10 years from now and then bringing you back to this class, and then we can discuss about have you been able to make that happen, whatever you have been discussing about today. So please use the chat space and write us whatever you think about your position in 10 years from now in terms of the kind of being a cognitive neuroscientist. Or it might not be just being a cognitive neuroscientist. You might be a psychiatrist, you might be a physician, you might be whatever kind of practice that you want to do. But what would be the ideal case scenario for you at that time in 10 years from now? I want to have more details than just saying that, okay, being a researcher in addiction. Just try to visualize yourself, your exact position, the institute that you want to work inside, your qualifications, your position, whatever detail you can provide. Please add as more detail as you can. Yeah, more than pain management, Fabiana. I'm just expecting to have more, let's say, in detail. Okay, I just want to have a fellowship in pain medicine and then being able to have a clinic. So give us more details about what you are expecting from yourself to be. Okay, work on habit and self-regulation. In what position, in what qualification, where, how, provide us with more details. Let's start the discussion with part 1, talking about the ultimate goal of cognitive neuroscience. What would be the ultimate goal of being a cognitive neuroscientist, and how cognitive neuroscience is moving forward with what we are trying to do. Let's start by giving an idea about what we mean by cognitive neuroscience and trying to give a better kind of definition of cognitive neuroscience. So when we talk about neuroscience, there are neuroscientists who are mainly focused to this part of neuroscience. They are mainly cellular and molecular neuroscientists. So people who are doing, cellular and molecular neuroscience. Okay, so we have a group of neuroscientists who are mainly focused to this part of cellular molecular neuroscience. And there are people who are mainly focused to this side in terms of more being sort of psychologists or experimental psychologists, being going into that direction. But cognitive neuroscience is mainly in this kind of sweet spot, in my understanding, in terms of being able to understand what are the neural systems that are related to some behavioral dimensions that are reflecting these sort of processes. And when we talk about these processes, I would name all of them as cognitive processes. It's true that here in the RDoC model, when they talk about cognitive systems, they are talking mainly about, let's say, cold cognitive processes. But other aspects of different sort of processing related to emotion, social processing, sleep, sensory motor, we consider all of these aspects as cognitive processes in a general definition as well. So when we talk about cognitive neuroscience, we are talking about something between in terms of being able to work with neurocircuits and how these neurocircuits are related to different cognitive processes that would have a specific behavioral implication. So this is what we mean by cognitive neuroscience. And the question is, okay, if we are considering this as the main core of what we are discussing as cognitive neuroscience, what would be the ultimate goal of this field of science and how we can move forward with this idea? When we talk about cognitive neuroscience, we can go back to 17th centuries and 18th century and 19th century, and you can see that we have some sort of early cognitive neuroscientists that they have been trying to relate different sort of brain structures to different sorts of characteristics or behavioral characteristics or specific, let's say, personalities. And those people, probably the most famous guy in this field would be Franz Joseph Gall. And Dr. Gall, who was a German sort of physiologist, psychologist, he was trying to find relationship between mainly the structure of the skull and how a skull is being shaped, because he was thinking that the shape of a skull is a good reflection of the shape of the brain. And they have been thinking that, okay, if we have a good understanding of the shape of the skull, they would have a good understanding about shape of different parts of the brain. And he was trying to reflect different sort of brain functions to the structure of the skull. And you probably have heard about an area that we call it phrenology, trying to relate different sort of personalities and characteristics and human-related behaviors to different skull structure. And if you just get focused or just zoom in to that figure, you can see it's quite amazing that they have been trying to relate things like, let's say, language or calculation or, let's say, secretiveness or sublimity or ideality. I mean, those types of humane traits or human-related traits to different structures and different shapes of the skull. So that was something that people were trying to relate. And obviously using these kind of ideas, trying to understand people, saying that, okay, even providing some like handbooks for young ladies and saying them, okay, if you find a man with this, let's say, skull structure compared to this man with this specific skull structure, you can predict their behavior or how they are going to be as a husband. So just avoid a guy with this skull structure, but that would be the right selection for your husband if you have different options between different skull shapes. So that is how they have been trying to sell this idea of how the brain structure would be related to a specific behaviors, and then the skull would be related to the brain structure, and then trying to sell this idea based on the structure, how we can predict who is going to do what. So that is the idea of phrenology. It seems funny to some extent, but in reality, there is an extremely ugly phase for phrenology and the specific implications, especially when we go back to the era before World War II and even before World War I, especially in kind of the Nazi Germany. People have been trying to relate some racial kind of characteristics to the structure of the skull. And you can see some German psychologists or prologists trying to find relationship between race and different. They were measuring different structures in the skull and trying to find the master race and the characteristics of the skull and face and brain of the master race, and trying to say that, okay, this is the ideal structure, this is the ideal proportion of different skull shapes, and then even trying to demonizing others based on the structure of their skull and the structure of the brain and all the nasty things that they have done before World War II and during World War II. And I'm sure that you have all heard about those things. That, I mean, there have been scientists that they were supporting those ideas, and it is extremely ugly and extremely heartbreaking to see how scientists were contributing to that genocide and were contributing to those ideas during World War II. And I'm sure that we already have students from East Europe, and we have students from, I mean, different parts of Europe and different parts of Asia that they have been affected. And even as a person, I mean, those who are from Iran, they know that the idea of having something like before World War II and during World War II, and I'm sure that you have all heard about those things. That, I mean, there have been scientists that they were supporting those ideas, and it is extremely ugly and extremely heartbreaking to see how scientists were contributing to that genocide and were contributing to those ideas during World War II. And I'm sure that we already have students from East Europe, and we have students from, I mean, different parts of Europe and different parts of Asia that they have been affected. And even as a person, I mean, those who are from Iran, they know that the idea of having something like Aryans as something like the sort of a better race, or I mean those crazy ideas that people have been trying to follow. And then thinking about those ideas, even let's say classifying people based on the structure of their face and saying that they are unfit to the society, and just demonizing them based on the structure of the face that they have. And that is heartbreaking. So if you want, I would highly recommend you to see some stories that are available in different places, like kind of in Wikipedia. You can find the racial policies of Nazi Germany and kind of see what they have been doing, and how sort of cognitive neuroscience, to my understanding, were contributing to this idea that, okay, it is possible for us to be able to measure the structure of the skull of kids at the age of 3 years old, and then based on the structure defining who has the master race, and just send those who are in the master race to learn calculations and mathematics and engineering, and those who do not have that brain structure, sending them to do gardening and the other things from the age of 3-4 years, because they are not supposed to be at that, let's say, high qualifications, because they do not have those genes. I mean, these ideas were really crazy ideas that people have been trying. And I mean, that is one extreme side of how science could go to a really, really nasty side. And we all need to be really careful. This is not something like kind of very far from us that people have been doing these sort of ideas. And just going back to kind of the the more, let's say, palatable ideas of phrenology, but even doing those type of things is something that the question is it something doable or not? Is this the way that cognitive neuroscience is going to go, and this is the way that we are trying to do here? So are we considering cognitive neuroscience as a sort of modern phrenology? Thinking about, okay, now we can measure the volume of anterior insular cortex or anterior cingulate cortex or subgenual anterior cingulate cortex, and based on that defining what is going to happen to people. So those type of ideas, how they can really contribute to the future of cognitive neuroscience, and we'll discuss about them a little bit later on today. What I'm understanding from human brain mapping and what we are discussing about in terms of cognitive neuroscience in clinical setting, we try to, at least many of us, we are trying to avoid that side of, let's say, cognitive neuroscience. But we know that there are definitely great potentials in terms of mental health disorders. We know that we all, as human beings, are suffering from different mental health disorders, whether they are, let's say, depression, anxiety, suicide, different sort of neurological damages, multiple sclerosis, stroke, all those brain health disorders that we are all suffering from, whether we are white, black, or Latino, whatever kind of race or ethnic background that we have, we all share these brain health disorders. And we think that cognitive neuroscience could definitely contribute to that understanding of, let's say, giving us a mechanistic understanding about these disorders and how they could be defined into clusters of brain disorders, and how we can think about individuals in terms of the problems that we have in their brain, and then thinking about interventions and how we can prevent these mental health disorders and define treatments and contribute to the rehabilitation. So that is how we are hopeful about cognitive neuroscience to play a role in reducing the burden of mental health disorders and brain health disorders around the world. And of course, thinking about what we call precision medicine in terms of being able to define prognosis. We are talking about individual level prognosis. Thinking about, okay, this patient with this specific characteristic would have this prognosis in terms of the response to treatments, being able to plan for their treatment, select the most optimum treatment, and being able to monitor treatment response. So these are the ideas that we have in terms of the individualization of the interventions that we are going to do for people who are suffering from mental health disorders. But the question is how we can push forward the field of cognitive neuroscience towards the direction to be able to contribute to reduce the suffering that people have around the world with different mental health disorders or different brain health disorders. The reality is, if you want to be able to do this, whatever we are discussing about today in terms of mechanistic understanding, interventions, precision medicine, we basically need to have two tools. One, we need to be able to assess, and then we need to be able to intervene. So if you have a good assessment and if you have a good intervention, that's it. So that is exactly what we are looking for. We are looking for specific assessment tools, and we are looking for specific interventional tools, and we are gonna combine these two wings to be able to promote the field of cognitive neuroscience, and that is what we are gonna do together to be able to be successful. Okay, this is the end of this part one of the discussion that we had today.